Okay, we have here a graph for the velocity, and the instruction for this exercise is make a sketch of the corresponding position function. Okay, this is the velocity, and we need to understand that the velocity in terms of t, it's equal the derivative of the position function. Okay, so if we the derivative, remember that is related to slope. Is the slope when the limit of the distance approaches to 0. Okay, thinking in this information, I have here the object. This is the graph velocity in meters per second, time in seconds. This is distance in meters and times in second. So I can see that from t0, from time equals 0 to time equals 2, there was a velocity of 1. So first of all, I write the same intervals, 2, 4, and 6, 2, 4, 6. And I can see that from 0 to 2, the velocity was 1. So I go from 0 to 2. From 0 to 2, the velocity was 1. 1 here in this graph will be the slope of the line. So here, if this is 2, this one have to be 2, because what is the slope? Is delta y divided by delta x, and that will be 2 over 2, that's 1. Okay, that will be the first part of the graph. If we look at the second part here, from 2 to 4, we see that the object stopped for any reason. So from 0 to 2 in the time, from 2 seconds to 4 seconds, the object did not go further. The velocity is 0. So here, that means that if the object stops, that is a constant function, because here the time is always running, is the independent variable. The time does not depend on the running. The running depends on the time. So here, there is no change in the position. It's the same from second 2 to second 4. That's why this graph indicated to me. From second 2 to second 4, there is no velocity. And then from second 4 to second 6, there is 2. That means that from here to here, let's suppose this is 4, and then here this is a 6. So from second 4 to second 6, the velocity was 2. So will be a line steeper, because this one was 1, the slope is 1, here the slope is 2. The delta y is 6 minus 2, 4, divided by 4 minus 6 minus 4, 2. So 4 divided by 2 is 2. The slope of this line is 2, and the slope of this line is 1. This slope represents the velocity here, that is 2. Okay, so this is the sketch, position versus time of the velocity versus time. I recommend your graph that you go from this one to this one, from position to velocity, and then you check this one back and forth, and you will have a better idea. But what you need to understand previously to watch those videos is, remember that the slope, it's equal delta y divided by delta x. You need to be familiarized with the limit process, that the limit, what is the slope? Is the limit when delta x approaches to 0 of delta y divided by delta x. That's the limit. And the limit is when delta x approaches to 0 is the derivative. The derivative of the position function is the velocity. Okay, I hope this video helped you a little bit, and if you have any questions, you can check any other videos or send a message through the web. Thanks very much, and have a great day.